Good morning, welcome back. I hope you all have had a good week so far. For us here on campus, you notice I'm not wearing a mask right now, so that's kind of nice. I don't have any students in my classroom. We've commenced our hybrid schedules, so students are actually in their class periods while they're here at school. And that means I don't have anyone in my classroom during second period, as you are all virtual. So that's kind of nice, a little easier to do this without the mask on. So welcome back to the virtual classroom. Today we're going to be doing some practice problems with section 10.1. Having to do with comparing two populations and running like confidence intervals, significance tests, sampling distributions, dealing with two proportions from two different groups or two different populations. Hopefully you have some notes about this from last week. If you do not, we will have some resources linked in the thing that we will be working on. So there is that. Yeah. So let's see, I only have 10 people in here this morning. Hopefully the other 5 show up shortly. We're gonna get going here. So first thing I want to do is kind of show you guys what we will be working on. Let's get this guy zoomed in a bit. Should work. All right, I don't know where that went. There it is. All right, so we have a Google document here. I want you guys to try to work in groups today. So we will be using some breakout rooms to work on this set of exercises. Working with a group, I'm going to give you guys 30 minutes to complete the following 4 exercises. Now, with that being said, 30 minutes may or may not be enough time for you to actually finish all 4 of the exercises. Some of these problems are starting to take more time, right, because they do have the 4 steps, different things that you're doing, and so they're a little more time consuming than your standard, calculate this math problem. So 30 minutes may or may not be enough time for you and your group to complete all of these exercises, and that's okay. Part of the thing that I'm starting to do is build in timing so that you can start to build a sense of how long 30 minutes feels like while you're working on math. To try to prepare you for the time restrictions you're going to have when you take the AP exam. Some of you may or may not have experience with taking standardized tests where you have a limited amount of time. You need to do well at budgeting your time and knowing kind of how much time has passed so that you can pace yourself through the exam. So that's part of what we're going to start building a sense of right now. Another thing here, the 4-step process. Right? Anytime you're asked to perform inference, so if you see the phrase construct and interpret a something % confidence interval, carry out a significance test, even if you just see, is there sufficient evidence to support this statement, you should be defaulting to using the 4-step process, right? State, plan, do, conclude, right? Following the 4-step process and doing the things that each one needs is an outline to make sure you're including everything you should when answering a free response question on the AP exam. There are things that the graders are looking for. If you skip some of those things, even if you have the right calculations and the right math, you will not get the credit you deserve. Right? If you can calculate a t statistic and you just show that math, but you don't identify any variables and you don't go through the process before that of checking conditions, unfortunately you haven't shown what they're looking for. You're not going to get a passing grade for that question. So you need to start practicing using these things so that you're used to doing the things needed to get credit. All right, so that's what that statement is there for. Right here, we have a link to the study guide for section 10.1. This links back into Canvas where that study guide is housed. It has formulas and inference methods you might need. It also has some examples attached to those formulas that may help you as you work through these problems. You also have a link to the AP exam formulas and tables. All right, again, that is something you need to start getting used to using. That's what you'll have access to. You'll have table A, table B, there's another table on there we haven't used yet, and you'll have the 2 pages that's formulas. All right, you want to start using those over some of the things that you have already. All right, so you want to start keeping these things in mind, start practicing with these things. Lastly, the other thing you need to start practicing with is your graphing calculator. All right, hopefully you have one, TA84, hopefully your school issued one to you. You're allowed to use that calculator on the exam. You're not going to be allowed to use your phone. You're not going to be able to access any other web pages to use some online calculator. It's just not going to be an option. You need to know how to use that physical calculator to do these types of calculations. So you should start practicing using that. All right. Is there any questions before we get started here? All right, so that was 30 minutes. I know that it may not have been enough time to complete all 4 of these problems, and if it wasn't, that's okay. The main purpose of me timing today was, again, to give you guys a sense of what 30 minutes feels like while you're working on some of these free response questions. On each of the documents, I went through and left some feedback for the parts that had been completed for the most part. So it should show up as like a highlighted thing, and my comment should be viewable by you guys. If it's not, please let me know. I may have done something wrong. I don't know. So each of those documents should have a little bit of feedback on there for your consideration. What questions do y'all have right now about these problems? Are there any specific questions that you have? Okay. Then what I would like to do, see if I can get this to work. I'm just going to go over a couple of the questions with y'all real quick, and then we will be done for the day. So see if I can't make things work here. All right, so I'm hoping you guys can see my shared screen now. So first up here we have kind of the work and stuff that goes along with that first question that you guys have about the jelly beans and the proportion of red jelly beans between the child mix and the adult mix. Right, this first part here, I'm just identifying the things from our context. Right, we have population 1 is the child's mix, population 2 is the adult mix. The proportion of red jelly beans in the children's mix is 0.3, in the adult mix it's 0.15. And we have our 2 different sample sizes here, 50 for the children's and 100 for the adult. Question A asks about the shape. Right, when we're asked about the shape in a distribution, in this case, we should be checking for normality. Can we say if this is normal? Because if we can, that's the least amount of work we can do. We don't have to graph it. We don't have to, we don't even have data to graph it enough. So checking for normality in this case is checking the large counts condition. Are there at least 10 successes, 10 red jelly beans, and 10 non-red jelly beans in each sample, right? And if we do the math here, we get 15, 50, 15, and 85. Those are all at least 10, which means the sampling distribution of the difference between the sample means or the sample proportions will be approximately normal. And that's how we get that one. Right, the mean of the difference of the sample proportions is equal to the population, the difference between the population proportions, which is 0.3 minus 0.15, and we get 0.15. And lastly, our standard deviation of the difference of the sample proportions. We get this formula here, right? And we get 0.3 times 0.17 over 50 plus 0.15 times 0.85 divided by 100. And we ultimately get 0.07399. You could round that to 0.074. That is totally okay. As long as you have this work shown, if you make any kind of rounding error in how you write your decimal, it's probably not that big of a deal because you've shown the actual formula with the work. Okay. Is there anything I can clarify about on this example? So then we'll go on to the next question. All right, so this one is asking us to construct a confidence interval for part A. Right. Again, at the very top here, I have some scratch work. Whether or not you include these things as far as like scratch work is concerned. Oops, my lights just turned off. It's okay. All right. They're not necessarily part of part A or any of the other parts. It's just me writing down the things I'm going to need to solve these problems. Right. And so I've identified my populations, my sample sizes, and my sample proportions. Right, we do our statement. We want to estimate the parameter P1 minus P2. Right, these are our population parameters, where P1 is the true proportion of young men living at home, and P2 is the true proportion of young women living at home at a 99% confidence level. You could have also worded it as we want to estimate the true difference in the proportion of young men and young women living at home. Right, but writing it this way allows me to show the parameter and define the terms that I'm going to use, which we need to have done in order to use them later. Right, we then move on to our planning step. Right, we move on to our planning step here. If conditions are met, we will use a 2-sample Z interval for P1 minus P2. Right. Randomness, the samples were random. We were told that in the context. 10% condition, there are more than 22,530 young men and 26,290 young women in the US. Right. This is a statement that we can say with confidence here. We know that there's more than that. I got those two numbers simply by multiplying the sample sizes by 10. If it's less than 10%, or if it's at most 10%, multiplying it by 10 will give me the supposed minimum population size. Right, and in this case, I can make that statement that this minimum population size is much smaller than the actual population size. Lastly, we do the large counts condition. The number of successes and failures in both samples is at least 10. And again, I can say this with a lot of confidence. We can show the math if we need to. However, we have 986 successes for the men, 923 successes for the women, and many, many more than that as quote-unquote failures. So our conditions have all been met. Then we get to do some math. Right? If we are doing a 99% confidence interval, then that leaves 1% left over, which is 0.01 as a decimal, which leaves each tail to have 0.005, right, or 0.5%. This leads to a z-score using table A of negative 2.575, which then leads to a z-star of 2.575 because we just use the positive version of whatever we find on table A. And then we use this formula here to get our interval. We have our test statistic, p-hat1 minus p-hat2, plus or minus the critical value, z-star, times the standard error. This whole thing in the parenthesis or in the square root is our standard error. When we plug in all of our values and we use substitution here, we get 0.08655 plus or minus 2.575 times 0.013996. I'm keeping a lot of decimal places in my rounding of this to keep it as accurate as possible. And then we get the interval of 0.051, 0.123. Again, you must write intervals with the smaller value first, 0.051, and the larger value second. If you write this as 0.123, 0.051, that is incorrect. Even though you have the correct two values, they are not written properly as an interval. Okay, you need to write the small number first. Is there any questions about the state, plan, or do steps for this problem? Then lastly, we have to make our conclusion and answer the last question. Right. As a conclusion, we are 99% confident that the true difference of proportions, P1 minus P2, of young men and young women who still live at home is captured between the interval 0.051 and 0.123. That's our conclusion. The other question here, since the interval does not contain 0, there is convincing evidence that the true proportion of young people who live at home is different for men and women. Right, something I want to point out here is that I'm answering the question. I'm not providing anything else besides the answer to the question. Right, the question was asking, do we have evidence that there's a difference between the amount of young people living at home, the proportion of young people living at home between men and women? It didn't ask, is there convincing evidence that there are more men living at home than women or more women living at home than men? Right? If we add more details about who has a larger proportion, you're just opening yourself up to being graded on more things. Answer the question. There's no reason to answer more than just the question asked. Okay. Is there anything else I can clarify here? All right, so stop sharing my screen there. That's where we're going to stop for today. I will go over a couple of these other things probably next week. Tomorrow we're going to be doing some practice with section 10.2 having to do with population means and the difference between two population means or the means of two groups. It'll be a little different than what we did today. And then next week, we'll do a little bit of wrap up for chapter 10, and we will then do some stuff for preparation for the AP exam and things like that. So that's kind of what's going on next. If you have any other questions, comments, concerns, anything you need help with, please feel free to reach out to me and let me know. Get the help you need. And besides that, I hope you guys have a great rest of your day, and I will see you all tomorrow.